The title or like the theme for this series encompasses testing view applications with Vitest, right? We'll go into more detail about what we're going to cover in series one. But before then, I find it very important for me to introduce myself. So I am Uchechukwu Azubuko, Uche for short. So you can call me Uche. And I am currently the lead front-end engineer at One Liquidity. I'm a co-organizer at Vue.js Nigeria. I'm a founder at Thrivescape. So basically, Thrivescape is an NPO which I started, which is aimed at empowering girls to embrace the superpowers of tech. All right. So I'm giving into teaching, helping the community around tech. I also get involved with technical writing. So you can find a few of my content on my personal Medium, or I have also written for Stack Abuse. I don't know if we know about Stack Abuse here. So technical writing is also a few things that I dabble into here and there. You can find me on Twitter at Uche Azubuko, Medium at the link provided, my GitHub, my LinkedIn, wherever you need to, get in touch with me, probably after the meetup or after any series, or probably you need help with anything around tech or around Vue. I'll be glad to provide some sort of assistance in any way that I can. So it's series one, and hooray, I hope we're all excited to get started. So um so throughout this whole series, throughout this entire series, we'll be covering testing, right? And then the idea of this series is that it's beginner focused. So it takes us right from the fundamentals associated with testing JavaScript applications, what testing is all about, approaches to testing, pros and cons of testing. And then before we even think about what Vitest is, right, and how to test applications, Vue applications in our context, because I mean, this is Vue Kenya, this is Vue Nigeria, this is the Vue ecosystem. So we're going to like niche down, right, and specialize in testing Vue applications in themselves. However, for series one, more focus will be given to the fundamentals, the basis, because I strongly believe that once we have the fundamentals under our belt, we're able to, power on into doing greater things with what we have learned from the axioms. So we will be learning about introduction to testing, types of test, when to use test, JS testing 101 with Jest. So more like a quick demo, simple unit test, just to see how these things work, right? Then we'll learn about best practices to testing, introduction to Vitest versus other frameworks for testing, and then conclusion around what we've learned today. Along the lines though, if I am probably moving too fast, please call me out. If you need clarity on a few things, please call me out as well. I look forward to, and I'll be happy to, go back on whatever it is that you need help with. So I feel like we can get started. Introduction to testing. So along my journey as a software engineer, I find or I see that very few engineers actually get involved with testing. Very few software engineers get involved with testing. Even where we probably work, there's a very small percent of us wherein our teams, our software engineering teams get involved with testing projects. Why? Because everyone probably wants to build and ship things faster. Everyone wants to write code and put out there so everybody sees real quick. But the thing here is that it'll be very embarrassing if it happens that we wrote some piece of code and then say we wrote the code on Sunday night and we come, say, on Tuesday morning to find that our code is not working as it should work, right? So probably we omitted a few edge cases. Probably we didn't test some context, right? So these kinds of things can break our applications. It's true that, yeah, we might be able to guess the kinds of flow that an average user would use. But how about some users that their flow might not be the most common, right? If we don't test our application, it's very likely that we miss out on these use cases. And what happens is that our application breaks. So testing is basically a crucial component in software engineering, and it ensures that we ship codes that are highly scalable, of high quality, and say to a high degree is bug free. So at the end of the day, we want our software to operate properly and work according to plan. So the only way to ensure that our app works according to plan, system requirements, user requirements, is to test it. So types of tests. There are various types of tests, right? However, here we would have a look or be focused on two various kinds of testing. The first test, unit test, the second test, end-to-end testing. And this is because I find that in as much as there are other kinds of testing, say snapshot testing, regression testing, and a few other testing, they all come down to having unit test being a part of them in some way or another, or having to have end-to-end tests being integrated in some way or another. So we're trying to bring this down to, say, unit test and end-to-end test for the sake of this series, right? Perhaps moving forward, we could have a look at various kinds of other tests, but we'll just focus on unit test and end-to-end test. So unit tests are individual units. Is it testing of individual units or components of a software? So, when we probably write code and we have various functions for certain things. So for example, say we have built a calculator, right? In our calculator, we're definitely going to have a function that is working for addition, a function that is working for subtraction, a function that is working for division, multiplication, finding the percent of something and all of that, right? If we are to test that each of these functions work as they should, then what we're engaging in is unit testing. So that's essentially what unit testing is all about. So it verifies a section of code in order to validate that it performs as it ought to perform, right? And then they are quick and can be run in a few seconds. So they are like the quickest way of running tests. They are really quick to run. And they just help us determine whether a function or a loop or a statement works properly. In as much as it sounds like unit test is so easy and kind of sounds flawless, there might be like some cons to it. And I find some cons to unit testing to be around the fact that if our app scales, if our app grows, if code base grows, it then means that there is the tendency for us to rewrite unit test each time. And I mean, that's definitely a con. That's some sort of disadvantage to unit testing. However, they are easy to run, and I mean, who doesn't want things that are fast and easy to do? So the next kind of test we're going to look at are end-to-end tests. So end-to-end test is a way of testing wherein we kind of simulate the browser to run our application and look forward to our application running as it should run. Yeah. So basically, we're trying to reproduce an environment that simulates something similar to what our users would engage with. So we're testing like the entirety of our application. We're not just testing a function. We're not testing a loop. We're testing it in the way that a user would actually use our applications. Because at the end of the day, a user would not say, oh, because I want to add, I would only just like, I would only like just divide the calculator and just use the, the addition part and all of that. No, at the end of the day, they are going to use the entirety of the calculator. So in the case of a calculator, for example, an end-to-end test would be testing all the functions that involves with the calculator, testing how it works to ensure that it works as it should, even for a user, right? But the thing here is that because we're testing all the functions, we're not trying to like just verify certain sections. Of course, this has us spending a lot of time, right, to run our test. So the second point there saves a lot of time, and that's a mistake. So you spend a lot of time actually when you run end-to-end tests, and they can be difficult to debug and are time consuming. Exactly. So that's it. So end-to-end tests are difficult to debug and are time consuming because say the user is running a few tests, say you're testing and you come across an error one way or another, it's not easy to like point out where the error is originating from. But if you were running a unit test, you are clear to the fact that, oh, it was this function that has an error, or it was not this function that has an error. So that's where the difference lies between, you know, both unit test and end-to-end test. So moving forward, right, in our various in various weeks, in forward and future weeks to come, we'll have a look at unit test with Vitest, end-to-end test with Vitest. But right now, we're just trying to keep things simple and focus on the fundamentals because this is very like essential. I feel like at the end of the day, as a developer or as an engineer, when you are armed with the capabilities of testing, you know how to test applications, and you know how to do it right, it kind of puts you a step ahead of any other software engineer out there in the market. Because like I have been involved with say like hiring processes, right? And I see that when the question around testing just comes up, there's a few engineers who actually get involved with these things. I mean, some are involved with testing in private projects, and that's cool because like I said earlier, you find that in most companies that we work at, they are not really giving testing. But it's good as an engineer that you have that consciousness within you that your application should work as it should work. So when to use test? So we use test when we need to increase the quality of code. We use test when we need to concentrate on certain tasks rather than the past, certain current tasks rather than the past. We use test when we need to engage in modular construction or otherwise had to build applications. We use test when we need to eliminate manual verification. We use test when we need to guard against unexpected regression. One may be asking, what are unexpected regressions? So in software engineering, regression basically refers to the tendency of a software bug to reoccur, right? So, you know, when you build a product or when you build a feature, for example, it might not work according to plan in some certain areas. So the tendency for that to always like occur is what regression is all about. So the idea of testing helps to curb unexpected regression because at the end of the day, we are trying to ensure that we ship bug-free codes, right? So at the end of the day, we know that to a certain degree or to a very high level, our app would work as it should, and then regression is reduced. So these are like the benefits of testing. This is and these are use cases where we should be involved with testing our applications. Before we even move forward, one might probably be wondering if there's something like when should we test, when then should we not test? I probably think someone is probably wondering that. It can happen that you are probably just building like a pet project, nothing serious. It's just for say improvement's sake, self-learning and all of that. And your self-learning probably doesn't involve testing. It's fine to it's fine to not have to test in that case, because at the end of the day, the number of users who might use it is just you, right? But if, say, you are building a product or a software where a decent amount of users would be involved with, then it will be ideal that you test your applications. And for that reason, there are best practices to testing. So we shall look at these right now. So a good practice for testing is that our test should be deterministic. Our test should be deterministic. So what this means is that when we write tests, it should be written in such a way that the outcome is always constant, regardless of the argument, regardless of the parameters. All right, the outcome is always constant. So we're going to be involved with like series of simple tests, say how to test addition of numbers, how to test the subtraction of numbers, and ensure that it does and functions as it ought to, right? But the thing here is that our test should be deterministic, such that, say you're building a calculator, for example. I keep using calculator because it feels like that's the easiest thing we can all relate with. So if we're building a calculator, for example, 2 plus 2 in Nigeria should be the same as 2 plus 2 in Kenya. Isn't that so? So for that reason, when we write our test should yield the fact that when the number 2 and another number 2 are added, it must always yield 4 wherever the user is, right? So given the fact that our results or our outcomes are constant, it then means that our test is deterministic, and that's a good thing. So another thing that is a good approach to testing is that we should avoid unnecessary tests. So we spoke about that. We spoke about that earlier when we said that, say you're building a project that's just for yourself, there's probably no need for writing tests along that lines, because it might just waste your time. You're big on self-learning. So if you probably have like if you probably have time kept aside for learning how to test, that's calm, that's good. But if you're building for the sake of learning a skill here or there, it might just be unnecessary to run tests. Another good approach to testing is that while testing, you should avoid exposing internal logic. We should also avoid testing implementation details, and we should place business logic into pure functions rather than UI components. So these essentially are the best and good approaches to testing our applications. Oh, demo time. Okay. So so far we've learned about testing, we've learned about types of testing, we've learned about areas where we should engage with testing. We've learned a few cons of unit or end-to-end testing. And at this point, it'll be good for us to have a look at how we can run even the easiest of tests, even the most simple kinds of tests, right? Because we're all learning. So it's good that we start from the very basics so that we understand how it works by the time we are working with testing bigger functions, for example. So I will just switch to my VS Code for the sake of this. But before we proceed into our demo time, does anyone have any questions so far? Did anyone call me any questions so far around testing? Yeah, I'm all ears so that we could talk about such before we have a simple demo on testing. It sounds like no one has any questions so far. But do we understand the idea around testing though?
Yes, we do.
Stillman says yes. Deborah says yes. Alfred says yes. Des says yes. So good. So good. Awesome. Awesome. Okay. So I guess we can have a look at a very quick demo around testing. Second to switch to my VS Code. I have my notes here with me, so let's see what's next. Okay.
Hi, Uche. We
Yeah.
are not able to see your VS Code for some reason.
Oh,
Yeah, for some reason it's been blinded.
all right. Give me a second to fix that. I don't know why that is. So I guess I might have to reshare. Probably not resharing the entire screen. How about now? Do you see it?
Perfect.
Awesome. Let's go. All right. So I'll just quickly create a folder for us where we're going to engage with simple unit test of simple functions. Okay, so earlier I spoke about how we'll just have a look at how to test various simple functions. So in this quick demo, one of the functions we'll test is how to test the addition of two numbers and ensure that it's right. So the calculator analogy is something that we're going to have a look at here. We're also going to have a look at how to test the subtraction of two numbers. And another thing we can also have a look at is how to test the equality of, say, two arrays, right? To ensure that they are equal. So we can kickstart with writing a function, a simple function that adds two numbers. So we write our function and then we pass parameters. So at the end of the day, we want our add two numbers to always return a plus b, right? And then we want to say module.export add two numbers. Cool. Equals to rather. Cool. So we can create another function for, say, subtracting two numbers. And then function goes subtract two numbers a, b. And when we subtract the numbers, it should always return a minus b. Remember when we spoke about nature of a good test, it must be deterministic. So if at any point if at any point our number does not If at any point when we're testing, it does not yield what we look forward to yielding, then we know that we've written a very bad test. And then the last one was to test, say, equality of arrays, right? So say duplicate arrays. So here we're definitely going to pass an array and then return an array. We'll see how this works. All right, cool. So the first thing we need while testing is to know that with JavaScript, we can test with there are various libraries that we can use for running tests. So they range from Jest, Mocha, Vitest, right? The one we're going to focus on moving forward. But for the most part of it, the most popular in the JavaScript ecosystem happens to be Jest, right? And then I know that React is not the buzzword here, but the React community feel like they own Jest. But the truth is that with Jest, you can even test Vue applications, you can test all sorts of JavaScript applications. So in this demo, we'll be using Jest to see how to run simple tests. Moving forward, our focus is Vitest. So because we're going to use Jest, and Jest is a package, we'll have to initialize package.json in this our project. And to do that, we run npm init-y to simply do so. All right. And then we've initialized package.json. So you know how when we need to run, say, our projects, and we say npm npm start or npm dev, npm run dev, and all of those things. When it comes to running tests, however, at this point, it does nothing, right? Writing npm test to run our test does nothing, because currently what we have here just says echo error, no test specified, and exit one. So basically at this point, we have not installed our testing library yet. So our application doesn't know what we're essentially telling it to do. So for that reason, we need to install Jest. And to install Jest, we install it as a dev dependency, because we're not going to need our testing in production. We just need it for development's sake, to ensure that things work as they ought to. So in installing Jest as a dev dependency, we say npm i -save -dev Jest. So the Jest library is being installed, and cool, it's been installed as a dev dependency. So with this now, we can replace this piece of code here on line 7 with Jest. So whenever we write npm test on our console, Jest is being run under the hood. So imagine I write npm. Let me just clear my console. I think I should also make it big, so that, yeah, cool. Bigger. Yeah, this is good. Let me just clear my console. So when I run npm test now, and I should save my package.json. Yeah. So see, Jest is being run. But now what happens is that Jest tells us that it runs, just tells us that it can't find any test. So no test is found, right? Exiting with code 1. So this is because in as much as we have installed Jest in our project, we haven't done what is needed for us to still be able to test any of the functions within our project. So the next thing to do is to write script for testing in a JavaScript application. So you know how when we wanted to create each of our functions or each of our modules, for example, we had written our JavaScript files with the extension .js, right? We had named them with .js extension. So when it comes to testing JavaScript files, say we want to test our add2numbers file, or our add2numbers function rather. How we're going to name our test file for that function is that the extension ends with .test.js. So this tells our project that that's a test file. So .test.js instead of just .js identifies that that's a test file. So when we hit save, our application now is aware that we have a test file. So now we can try to run npm test now and see we get a different response than we got before. Why? Because our application now is aware that there is now a test file. However, it fails because we have not written any test in our test files. So now we've learned how to install Jest. We've learned how to have our applications recognize that we want to test. But now, how do we test? That's what we're going to engage with so far. So see, it failed in running this. So this means that if we actually had various other .test.js files, you run all of them parallel. But let's just start off testing our add2numbers function and ensure that it works. So recall that we have a function that returns the addition of two numbers. So in testing, let's try to first import our add2numbers function. So say add2numbers is equals to require add2numbers, right? So in testing, in order to test, we make use of the test function, right? And I believe that this function is useful across any kind of JavaScript application, because I recall testing a React application once, and I also use the test function. I haven't worked with Angular before, so I don't know how it works with Angular, but the first step is to write a test function. And a test function takes in first the name of the test that we want to run. So say the name of this test is to determine the addition of two numbers. That's what we write first. And then the second argument it takes is a function. And what happens in this function? In this function, we write the test that we have defined, but code-wise, of course. So what we wrote here is we want our test to determine the addition of two numbers. However, in this function, we are now going to write it in code, what we want to expect, what we want to see as a result. Of course, basic level JavaScript has us saying, if, for example, add two numbers to 3 equals to 5, return, log stock is on, pardon me. Correct. Right. So with this, if we were to test with this, it would work. But the thing here is that with the use of Jest, we have various methods that we can tap into, right? Instead of writing bulky code like this and then trying to say else, say throw error, we could write something like this. But this at the end of this seems ambiguous, right? But with Jest, we're able to simplify our code and make use of a Jest method, or rather another function for testing called expect So we want to expect that add two numbers 2, 3 should be 5. So we've transformed, say, 5 lines of code to a line of code. And when we run this test, our test passes. Why? Because our add two numbers function has an idea of adding two numbers, right? And we are testing that if, say, our user puts in a number 2 and another number 3, it must be 5, right? So we're testing that this outcome should work as it should. So imagine we put, say, 9 here. I run our test. It fails because it's not doing what our function at the end of the day was made to do, which is to add two numbers and add it properly. So back to our calculator analogy, if in the case where we needed to test two numbers and we needed to be sure that they were right, this can suffice for us and we're good to go. We can just quickly speed up to run test for subtraction of two numbers. I can just do that here. Subtract two numbers. And here again, we would once again use our function, and here it should be -1, of course. So when we run test, npm test, one should fail and one should pass. Okay. So what happens is that, okay, good thing we've learned again. So what happens is that because we have defined like a test function here, we are only able to like run one outcome per test block. So the needed thing to do would be to close that up, comment that, and then run our test again, and then it passes. So one outcome per function. I think that we're running out of time. So for that reason, we can just move into the rest that we have to cover for today. And then that brings us to Vitest. So Vitest is a blazing fast JavaScript framework for testing, and it was created by Anthony Fu. So if you're not new to the Vue ecosystem, you would know Anthony Fu. He's been around the various Vue frameworks that are very useful. Vitest, I think he's a maintainer with Nuxt, but I know he's one of also the creators of Prime Vue, also involved with CSS, right? I think he was the creator of CSS too. So Anthony Fu was the one who created Vitest. And why Vitest? Because if you've heard of Vitest, you've likely heard of Vite, right? And Vite has become that go-to replacement for Webpack, because at the end of the day, it helps us to run our applications in a much faster development process or workflow. And for that reason, there was a need to have a testing framework that integrates well with Vite. So if we were to use just in Vite, we would have a lot of configuration files here and there, and that's not very helpful. So what Anthony Fu came up with was a way to actually have Vite in itself have its own testing library that works well with it and is framework agnostic. So in as much as we're writing Vite with Vue applications moving forward, we need to also know that with Vitest, we can use it with React applications, Preact applications, Svelte applications, Angular applications, and whatever kinds of applications in JavaScript ecosystem. So why Vitest? Because there was a need for a Vitest runner, a native Vitest runner, and then Vitest makes the testing process during development super fast. So I'll tell us about this. So with Jest, it happens that we always, in order to always run a test, we have to do npm test each time, or better still, we have to use a watch. We have to prefix or suffix with a watch. But when it comes to using Vitest, testing is actually done real quick with the hot reload concept. When we start working with Vitest, we'll see how this comes into play. This is how fast Vitest is. So before, while he was testing this same function, it took him 18.55 seconds, but with Vitest, it was 13.96 seconds, and then a second try was 12.76 seconds. So this is just to say how quick testing with Vitest can enable developers. Because at the end of the day, you've built your application. You don't want to spend a lot of time testing. That's a lot of time you can use to work on other features and ship code real quick. So Vitest works with Vanilla.js, Vue, React, Sphere, Lead Element, which we had a look at that. Vitest also has TypeScript and JSX support out of the box. So this is another difference between Vitest and other JavaScript testing frameworks. So it has TypeScript or JSX out of the box, hot reload by default. You don't need to attach any extra watch flags. You can get started in minutes. It's easy to migrate from Jest to Vitest, and it provides great performance with multi-threading workers. Vitest versus other testing frameworks. So unlike Jest, we had a look at Jest while we were writing our simple unit test, but unlike Jest, it doesn't require a lot of dependencies to set up. Unlike Jest, when using with third-party libraries, it's not difficult to set up. So like I said earlier, if you are using Jest with Vite, it will take a lot of configuration files to set up. If you're using Vitest with say Webpack, you wouldn't even spend a lot of time setting up compared to if you're using Jest with various kinds of bundlers or loaders. So unlike Jest, auto mocking does not slow down performance. So if say you want to mock data, mock data so that you can test various kinds of data, because Vitest is fast in itself, it's built under the native ESM, which is an ECMAScript module that is powered by the most recent browsers. You'll find that working with Vitest is super fast and performance isn't slowed down. Exactly, it says performance is fast, live reloads are faster than Jest, and then it's highly compatible with Vite project. Because the world is moving towards Vite and away from Webpack, it will be ideal that we learn such a great tool that can help us stay relevant moving forward. All right, so we've gotten to that point where we've covered various things around testing, the fundamentals of testing, how to test applications. We've had a look at how to actually do it. We've had a look at best approaches to testing. We've had a look at Vitest. We've had a look at the benefit that Vitest brings for us. It was just very important for us to embrace these basic features around testing, this basic idea and concept around testing. Because like I said earlier, the moment an engineer knows how to test, he's miles ahead of other engineers. You go for, say, an interview, and questions around testing come up, and you're able to answer appropriately. It just puts you ahead of other engineers, because the truth is, there are very few engineers who engage with testing. Very, very few. Very, very few. So it would be good that each of us here at the end of the day, we live with the idea and actually knowing how to test. If we need help with testing, we can feel free to reach out to any of our hosts. We can feel free to reach out to me. I had shared my social media handles for various platforms: LinkedIn, Twitter, GitHub, wherever you might want to reach out to me. Feel free to reach out to me if you need help. at the end of the day, we are just going to build an ecosystem where we are helping ourselves brick by brick become world-class engineers. So so far in today's series, if anyone has any question, feel free to ask any question. I'll be glad to hear them. If anyone has any contribution, if anyone has anything to just say, feel free. Along the lines, over to you, Brian.
Awesome. Thank you, Uche. I'm getting some questions over here. So Solomon in chat is asking, he's saying, great talk, Uche. I do have a question. How can we effectively determine whether a test is required or not?
All right, cool. How about we have all our questions and then we answer all of them together? If anyone probably hasn't, okay, Ruben is raising his hands.
Okay, my question is, like, you have demonstrated how to use a test with like a desired outcome, like you know what the outcome will be, 2 plus 3 will be 5. What about testing a function that will return data that is unknown, maybe from a server or from an external API? So how will you go about that? Thank you.
Yeah, okay, cool. Okay. Great question. Who else has another question?
Hey,
Just say two.
I think I'm gonna ask a very complex question.
Yeah, sure.
So with something like Vue, how would you like test like BDD in terms of spinning up like a Docker image and imitating like the sort of behavior that you're trying to validate?
Okay. Regarding your question, I think I wrote something around that. In as much as it would have been awesome to have a look at that. I'm just trying to find out where that was written. Okay, so I probably didn't add that, but it was in my draft. So essentially it was definitely in my draft. So essentially, I avoided reaching out to the scope of Docker, right? For this, because the idea was to leave it simple. So perhaps we can have a look at that in one of the series. Perhaps after we have looked at unit testing with Vitest and end-to-end testing with Vitest, we'd have a look at having a reproducible environment and testing with such using Docker. So I actually wrote that somewhere because for some reason, why did I just, oh yeah, see it here. Okay. So Docker is just basically away from the scope of today's series, but we'll have a look at that definitely now that it's a question. Someone's question says, how can we effectively determine whether a test is required or not? And Ruben's question was, how can we run, say, we are expecting a response from a server, how can we run test against such response? We start with Selman's question. So in determining whether a test is required or not, the best thing would actually be a section of this was actually covered here. So if it involves, if for the most part of it, if our task involves high level checks, of course, that passes as something that we should always test. For the most part of it, I would say that you should just avoid testing if you were doing a pet project. But if you were running production grade projects or enterprise grade projects, it's ideal that you get involved with testing whatever it may be, because you never know what can break code. So for that reason, it's not ideal to leave out something just because you feel, okay, that would always work well, that would be good. So what we do where I work is that we always ensure that edge cases are catered for. All right. We work with small numbers, we work with outliers, we work with values that we feel that users could probably be involved with. So for this reason, it's not safe to now assume that, oh, because I on a normal day might work with 10, say I'm trying to add values, and I on a normal day might work with 10. I assume that, oh, Mr. B would always work with 10 too, or say 15 at the very most. What if he probably has, and probably let's assume he's a fintech or something, and it's money we're talking about here. What if he probably has a lot of money and he wants to work with, say, 3,000? It will be ideal that values as extreme as 3,000 are tested for, and values even as small as 1, 2, 0 is tested, so that our tests at the end of the day are deterministic. So let's just endeavor to test our applications, whatever the use case may be, and not leave out anything. I think that's the answer I would give for Solomon's question, except we're probably running a part-time project, a personal project even, not a part-time project, a personal project. And Ruben's question was, how can we test for resources that are coming from a server, for example? So we didn't have a look at that today, but we can always have a look at that in our next session. We'll have a look at that actually. So with Jest even, you are able to run tests for asynchronous data, right? We are able to use async and await. I'll just give an example because we probably don't have much time, but I can show like what the structure looks like. So say we want to determine the addition or determine the response from a server. What happens is that they await this, and this is how we work. So say we had a function response. Use the helper real quick. Gets items. Right. This is how we write our function for a case where we are running an asynchronous test. So because our function, we know that it should return LOL, then our expected outcome should be LOL here. So when we run this test, it passes. So you know how when we are working on a team, or if you're full stack here or some stuff, but if you're just a front-end engineer, because I assume almost everyone who works with you is front-end, I just assume that. But if you're full stack or some stuff, so you know, when working with data from the backend, for example, we always work with, say, a postman or swagger that outlines the kind of or the nature of values that we should expect. So those values that we should expect, we should put them here because this is what we would like to see. And then the nature of what our function, of how our function should go, should be here. If we get something that is not the outcome of what our API call should give us, then our function fails. This is just a simple way of running as an asynchronous test. But I hope that we get the idea, right? I hope we get the idea. Ruben, I don't know if I have helped to answer the question.
Okay, what I've understood is that like in testing, you must have like the outcome you desire, whether be asynchronous or not, you must have an expected result. So yeah, thanks for clarifying that. Yeah.
Very, very, very important. Very, very important. Because at the end of the day, when we build apps or when we build whatever product it may be, there is always a PRD that guides, right? A product requirement document that tells about the software requirements and the user requirements. So this means that at the end of the day, whatever product we are building has a way that it ought to go. So it's us testing what we have done so far against how the product ought to go. That's essentially what testing is all about. And that's why it's very ideal. It's very helpful. So that at the end of the day, our product will not be out there and we are seeing console.log on a user is seeing console.log on the screen, or a user is seeing, I don't know if you've ever used applications where you're actually seeing code on the screen. You're actually seeing code on the screen. Instead of an error message, you're actually seeing status 404, status something, and all of that. Why? Maybe because they hadn't tested that particular action that a user might have been able to do. So when you take time, you have a QA on your team, and this is talking about lab teams, probably have a QA and all of that, and there's time spent testing. All these issues, all these unexpected regressions are curbed and reduced significantly. So yeah, that's it. I guess. Ruben, do you have any other thing?
Good.
I'm not sure I can hear.
No, yeah, you have answered my question. Can you hear me now?
Yes, I can.
Oh, thanks.
You're welcome. I think I can also share the link for the Jest documentation here with us. It's just the iOS. It's not. Okay, just yes. So we can feel free to look at Jest, but definitely, from next week we'll be having a look at Vitest. I can also drop the Vitest. I have that on my slides. Hi Brian, would everyone be getting access to the presentation?
Yes, that's right.
Okay, cool. Yeah. That's it from me. except anyone has another question.
All right. Thank you so much, Uche. That was a very interactive session. To anyone else who will possibly have a question, we have a WhatsApp group where Uche is available. He will be available to answer questions within the group. But if you have questions that align within our next sessions, be sure to stay tuned for our next episode next week as we continue with testing with Vitest and with our same guest speaker, Uche. So that's it for today. Thank you for joining and thank you for your time. Hope this was beneficial to you guys. Thank you.
Thank you, everyone. Thanks for having me, Brian, and the team at View Kenya.
Awesome.